Hi, welcome to Angelis Math Tutorials. For this video, we will be answering two basic calculus problems. The first problem will be optimization and the second one will be related rates. So without further ado, let's get into this video. Problem 1. Find two non-negative numbers whose sum is 9 and so that the product of one number and the square of the other number is a maximum. We let x be the first non-negative number and y be the second. From the problem, we can infer that their sum is 9 and the product of the first and square of the second is a maximum. First, we have to get the value of y. To get this, let us transpose the equation to y equals 9 minus x. P, as the product of the two numbers, is equal to x y squared. So basically, the function of p is equal to x y squared. We now substitute the value of y, so it becomes x times 9 minus x squared. Simplify the equation, and we'll get x cubed minus 18x squared plus 81x. Now, let us get the first derivative of the equation. So we get 3x squared minus 36x plus 81. We can simplify this equation by dividing it into 3. With this, we get x squared minus 12x plus 27 as the simplified equation. To get the values of x, we factor out the equation like this. Equate it to 0, and now we have 3 and 9 as our x values. To get the maximum, we have to first get the second derivative of the equation. We get p prime prime of x is equals to 6x minus 36. In this equation, we now have to substitute the values of x that we got from the previous solution. For x is equal to 3, we get 6 times 3 minus 36, negative 18 as the maximum. For x minus 9, we get 6 times 9 minus 36 is equals to 54 minus 36, and that's 18 as the minimum. We have derived the equation a while ago, and we've got y is equals to 9 minus x. We substitute the value of 3, so we get 9 minus 3 is equals to 6. Therefore, the two non-negative numbers are 6 and 3. In our next problem, we'll be dealing with related rates. A 15-feet ladder is resting against the wall. The bottom is initially 10 feet away from the wall and is being pushed towards the wall at a rate of 1/4 feet per second. How fast is the top of the ladder moving up the wall 12 seconds after we start pushing? We are given a time of 12 seconds, x equals 10, the length of the ladder 15 feet, which is the hypotenuse, and the derivative of x with respect to time, which is negative 1/4 feet per second. From this, we can also infer that y of t is the square root of 15 squared minus x squared. We must find the derivative of y with respect to time, which is after 12 seconds. To get the distance of the ladder's initial position to its final position after 12 seconds, let us multiply the rate of the ladder being pushed to the wall to the given time. So d is equals to rt. We incorporate values, negative 1/4 times 12, we get negative 3 feet. So we can now say that the ladder moved 3 feet towards the wall. The ladder is now 7 feet away from the wall. To get the value of y, we can use the Pythagorean theorem, or a squared plus b squared equals c squared. In this case, our a value is our x value, our b value is our y value, and our c is 15 feet, which is equal to the length of the ladder, which is the hypotenuse. Our x value is equals to 7, and we are looking for y. To get this, we can transform the equation into y equals the square root of 15 squared minus 7 squared. With this, we get 4 square root of 11. To obtain the rate at the top of the ladder moving up 12 seconds after we start pushing, we must use this equation, 2x times the derivative of x with respect to time plus 2y times the derivative of y with respect to time equals 0 to be able to differentiate the values with respect to time. We must now equate this equation so it now becomes 2y times the derivative of y with respect to time, or dy over dt, equals to negative 2x times the derivative of x with respect to time, or dx over dt. To get the value of dy over dt, we now have to divide both sides by 2y. We get negative 2x times dx over dt over 2y. We cancel out 2 and substitute values. Negative 7 feet times negative 1/4 feet per second, or in decimals 0.25, divided by 4 square root of 11, we get the derivative of y with respect to time equal to 0.13 feet per second. Therefore, the top of the ladder is sliding up the wall at the rate of 0.13 feet per second after 12 seconds.
So that's it for today's video. I hope you guys liked it, and I hope you learned how to answer basic calculus problems which involve optimizations and related rates. Please don't forget to click thumbs up and subscribe to this channel, Angelis Math Tutorials, and comment down below if you want me to make more videos of your request. Stay tuned for more videos, and I'll see you guys next week. Peace out.